We always hear about the cloud, right? This idea that our data just lives somewhere up in the sky. Well, today we're going to bring it all back down to Earth. We're going to look at the actual physical stuff, the wires, the glass, the signals in the air that make our digital lives possible.
You know, the internet just kind of feels like magic. It just works. But when you send that email or stream that movie, it's not just floating off into space. It's taking a very real, very physical journey. So what is it actually made of?
The secret is what engineers call the physical layer. This is the bedrock of everything. It's the absolutely brilliant science of turning the ones and zeros of computer code into actual physical signals, like a pulse of electricity or a flash of light that can travel through something real.
All right, so let's dive in and start uncovering this invisible network that holds our world together. So why do we even care about this stuff? Well, it's a huge deal because this layer sets the ultimate speed limit for your connection. It determines how much data you can cram through at once. That's your bandwidth. And it decides how long it takes for a signal to get from here to there. That's your latency. Literally everything else in the network is built on top of this foundation.
So let's start our journey with the original workhorse of the internet, something that's still all around us, the good old copper wire.
And for most of us, that experience starts with a cable that looks super familiar, an Ethernet cable. But that simple twist you see in the wires, it's not just for looks. It's actually a low-key stroke of genius.
Okay, so here's the magic behind it. When electricity flows through a wire, it creates a little magnetic field around it. And those fields can get messy and interfere with each other. But by twisting two wires together, bam! Their fields work against each other and cancel each other out. It's a ridiculously simple trick that protects the signal from outside noise, giving us the stable connections we need.
Now, a step up from that is coaxial cable. You've probably seen this one too. It's what has traditionally brought cable TV and internet into our homes. It's got better shielding so it can carry more data over longer distances than the twisted pair.
But here's the thing. Sending electrons down a copper wire has limits. There's a fundamental bottleneck on speed and distance. To really build a global network, we had to move on from electricity to light. And that brings us to the marvel of fiber optics. The concept here is just so elegant. Instead of pushing electricity, we are now sending incredibly fast pulses of light down a strand of pure glass that's as thin as a human hair. A flash of light is a 1. No flash is a 0. Simple as that.
And the advantages? They are just off the charts. Because light isn't bothered by electromagnetic noise, the signal stays incredibly clean. This allows for mind-boggling speeds over huge distances. These fiber optic cables are the planet's central nervous system, with thousands upon thousands of miles of them crisscrossing the ocean floors connecting continents.
But you know, not all fiber is created equal. There are really two main flavors. For those super long-haul journeys across an ocean, you need a very precise type that can shoot a powerful laser signal for hundreds of kilometers without losing strength. But for shorter runs, like wiring up an office building, a cheaper version that uses a simple LED works just fine. There's a tool for every job.
So when you put them side by side, it's really a story of trade-offs. Copper is way cheaper for short hops, no question. But if you need massive bandwidth, long distances, and better security, fiber is the undisputed champion. I mean, it's a lot harder to tap into a beam of light than it is to tap into an electrical signal.
Of course, let's be real, a huge part of our online life happens without any physical cable connecting us at all. So now let's talk about that third medium, the air itself. From the Wi-Fi in your house to the 5G on your phone, pretty much all wireless data travels as a wave on this invisible highway called the electromagnetic spectrum. It's this shared, invisible resource that makes our untethered world possible. And we're using it all the time. Wi-Fi, our cell phones, Bluetooth, they all send data through the air. They're just using different lanes or frequencies on that electromagnetic highway to keep from crashing into each other. It's just like how different radio stations need their own channel to broadcast clearly. So you might be wondering, how can I just set up a Wi-Fi router without some government license? Well, the answer is the ISM bands. Regulators brilliantly set aside these little slices of the spectrum as a kind of public park, free for anyone to use as long as you keep the power low. That single decision is what gave us Wi-Fi and Bluetooth. But going wireless isn't a free lunch. Unlike a nice contained signal in a cable, radio waves just go everywhere. They can get blocked by walls, they bounce off metal surfaces, and they can get messed up by other signals like your neighbor's Wi-Fi or even your microwave oven. Making wireless reliable is a massive engineering challenge.
So this brings us to the big showdown, right? Wired versus wireless. Which one's better? Well, it's all about picking the right tool for the job.
And really, it just boils down to this. Wireless gives you freedom. It's unmatched for mobility and ease of setup. But for a rock-solid, predictable, super high-speed connection between 2 points that don't move, nothing beats a physical wire or a fiber cable. It's the classic trade-off between convenience and raw performance.
The thing is, it's not a competition. It's not one versus the other. The modern internet is this beautiful, seamless mashup of all these technologies working together. Your phone uses 5G to talk to a cell tower, which is then connected by a massive fiber optic cable to the global backbone. It's a team effort.
And to connect the most remote parts of our planet, places where you just can't run a cable, we have to look up to the sky. Satellites are the ultimate gap fillers. They bring internet to ships at sea, planes in the air, and communities far from anywhere. They are absolutely essential for a truly global network.
So when you step back and look at the whole picture, the internet is just this incredible physical machine. It's this amazing system that starts with a simple twist in a copper wire, stretches to laser beams flashing through glass between continents, and reaches all the way up to signals beamed down from space.
Our entire digital world is built on this physical foundation. And as our hunger for data just keeps growing and growing, the real question is, what's next? What will be the next physical link that engineers invent to keep up with our limitless digital dreams?